Hi, everyone. So here I'm going to go over the Lab 2 notebook for especially those who are less familiar with programming. I expect everybody has a basic understanding of computer programming here, but some may have more advanced knowledge than others. So I'm going to go over the code. Some code you are going to have to add here. Some of you may need to explore some things online, but essentially everything is already done here. Some modifications that need to be done are already presented here, and you just have to apply to a different context or a different data set. So let's get started. First, I'm going to import pandas and NumPy, which are two major libraries for doing data analysis. I'm also import the regress library here, for regular expressions. Here I'm doing a setting for the display of numeric information, kind of removing the scientific notation and adding only 3 decimal points. Otherwise, the numbers become too long. Here, I'm importing my data sets. I'm providing all the data sets already, which were actually difficult and kind of to obtain. And I was going to add part of the cleaning of the data sets for this exercise, but it was way too much. So here they're ready for you. I'm going to provide the data sets. You need to add code for the other ones. I gave names already. You can change the names if you'd like on your own side. Here we're printing the list of instances of rows in each data set. And in Pandas, a data set is a data frame, we call it, and often abbreviated as DF, but you can put any name you want. And so mostly there are state level data, except for this one here. So they should have about 50 rows or 51, that's plus District of Columbia. But some have more because they include things like Virgin Islands and some of the other US territories. The county level data has counties, so it doesn't have states. So we're going to need to aggregate that into states. Here, if we just write out the name of the data frame and do the shift enter on the Jupyter notebook, it runs and it just prints out the data frame. Here for state codes, we have a state variable, a standard kind of notation. I'm not really sure what that is, but then the postal code, which is the 2-letter abbreviation for each state, which we're going to use these to be able to join all the data frames onto each other. Here we can also print just the head, that is just the first few rows. So for the state GDP, we'll print just a few rows. You can see the columns that it has, and you can see some of the values. Notice that already here we have a state with asterisk, so it's listed a little bit different. So when we actually need to join and merge them, this is going to be difficult because Vermont space asterisk is not the same as just Vermont. And also notice how this state name here is state with a lower s, and the state name here is state with a big S. And we're going to need the fields to have the same name for us to be able to join them. So we're going to need to make some modifications on that as well. Also note, heads up here, that these are probably not numeric values, because numeric values in the pandas, it's usually just going to be numbers and no other kind of characters, not even a comma and not even a money sign. So already indication that these are already going to need to be transferred to numeric values to be calculated. Otherwise, the program will interpret it as just string or text and cannot do any calculation. If we run state population, then there's just 2 variables. This looks like it's numeric, and you can always check. You can do state pop dtypes. I have this written out elsewhere, and then we show all the data types for all the columns. But here, just 2 columns. One is the state name and one is the population in 2020. And notice also we have some issues here. First of all, state name. Now this is a different name. I'm going to use this as the standard for all of them, state underscore name, but it's a different name than the other 2 previous ones. Also, I see some other kind of characters here. This is going to make it difficult to join the data. There's some brackets and numbers. So we might want to remove that as well. With state taxes data, state has the state name here. And we have total taxes and property tax, different kinds of taxes. Notice also the comma here. Comma already gives me an indication this is probably is non-numeric, and we're going to need to modify this as well to make it numeric. Also, if you look down, you start seeing, wait, it's always good to take a look at the data. You start seeing, oh, what is this here? There's some underscore n, slash n usually means a new line, but somehow you got interpreted here just literally and put in under the name, in the name as part of the name. So this is not gonna, we're not gonna be able to match New Jersey from this data frame to another data frame if we need to, because maybe the other one has a space and this one has a slash new line. So we're gonna need to modify that as well. And then you can take a look at county poverty, just the first few lines, and you see, okay, this is name is of the county, so name means county name, and then here's postal code. So also notice this is postal code, but our codes data, state codes is postal, so we're gonna need to adjust that as well. But then we have poverty estimate. This looks like it's numeric. This definitely looks like it's numeric, and the float, we call float, which is the decimal point, 17.8, and this is poverty percent. Note that poverty estimate, this is the number of people in poverty, total number of people in poverty in each county. So this is actually the full number, 6,242. And median household income, and also that's the full number, so that's 67,000, 71,135, and so on. And this looks like they're already in numeric data type because there are no commas and no money signs or other characters. So to normalize state and code names. So first, what I'm going to do is I'm just going to create a new column in each of the data frames with a new name. So to do that, I give the name that I want for the new one, and then for the old one, the one that I'm taking from, state codes state. So this is the reference to this column, and take the value from the right and put it in the left, always in programming, right? So, and then you can see here the printout. I already run the operation and I print out the first few lines, the head, and you can see I got a new variable here, a new field. This is the same as this, but it has this name that is going to be standardized for us, and then we can merge them. Now we get into more complicated territory here, because remember, if you remember, that's asterisk on the state name for the GDP data. We want to replace that, and we're going to create a new field, and then we're already going to carry out the replacing operation. So the new values that go there, and you can see here the result, already have it with asterisk replaced. And I'm going to use regular expressions for that, regress. And some of you may be familiar with this, some of you not. If you're not, I'm going to point out to a primer on regress over here. And then also there's some cheat sheets. There are a lot of resources online. The basic concept is fairly simple, but it takes time to just get the hang of it. You don't need to remember all the special characters, but once you get the hang of it, you can then look up on the cheat sheet how to modify it. And what is happening here is that we're employing this string replace operation to be applied to every row of this column here. And the regress is going to do this. It's going to find this set of characters, and then it's going to replace it with this set of characters here after the comma, which is nothing essentially. This is two string codes with nothing inside, not even a space. If there was a space, it would look like this. So that means replace with a space, and this replace with nothing. And then we have to add the parameter here, regress equals true. And what this means is, this does not mean remove where you find a square bracket, left square bracket slash asterisk, right square bracket. This is not, this is regress code. So this means that just find, when you have a square brackets in the regress, that means that you want to find any individual character within the square brackets. So it's kind of like having just this. So this means replace the asterisk only. But the problem is that asterisk is a special character in regular expressions. So we need to escape it, and we need to put this here. So this means that, so this whole function means replace the asterisk from this field. That's pretty much it, even though we need this bracket here. Now we could write that a different way, actually. I think if we write it just R, which means literal, whatever follows, just replace exactly as this. So we could use that. But this is not regress, so we would not remove it like this, but I wanted to introduce regress here. So In regress way, it would be like that. Seems more complicated for this one, but for other ones, it would be better. And then if you run it, you should, as done here, you see state name is cleaned up without that asterisk. So move on to the next one. And then actually, I'm going to ask you to add your own regress expression here. So it follows the same formula, but then you're going to add your regular expression here. And then for this one, this is the state population. So if we go back up, we'll see that state population needed to remove these bracket with numbers in. So we want to remove anything with left or right bracket and numbers, because none of the other states have that. So as long as if we can remove any left or right bracket and any numbers, then it really cleans this up. So that makes it easy and possible to employ regress. So here we're going to add a regular expression that removes any numbers 0 through 9, and also any left or right bracket. As you can probably remember, the bracket itself is going to be a special character. So you have to look on how to do that. You can add regress. If you don't want to, you can also add another way to remove those values there. But the simpler, the better. So I don't want to see multiple lines of code just to remove, for example, one from each. You move one from this one and then another operation to remove another row and so on. So do want to kind of simplify it as much as possible. Here is also, there's another issue with the state taxes. So the state taxes, if you remember, if you look up here, had that N, /N. So we need to remove any /N there, from there. But notice here, I actually, you don't need to use regress. You can, but you don't need to. So I want to remove any /N and I want to replace it with a space, because that's where the /Ns were. They were all where a space should be. See right here? So the new one should be right here. And then I already also take that operation that applies to it and then put it all in the new variable with a normalized state name. Notice that I noted too that DC was written DC as the name of the state, and usually it's not. It's District of Columbia. DC is the postal code abbreviation. Okay, so there are other issues too regarding the data types, as I had alluded to. And one way to address that is, well, first of all, I wanted to remove the money sign. So to remove the money sign, we're still going to use those string replace functions. And here I'm using the literal to put R, and then whenever it sees a money sign, it's just going to remove it, but just for this column alone. And then I'm just, by putting that in the same column, notice how these have the same name. I'm just essentially replacing it with the new ones. And I don't think it's necessary to create a new column with a different name for that one. So if you see here, the result, it removed the money sign. However, if you double check, the data type is still, I'm just focused on this one here, GDP 2020 millions. I'm just going to use this one. You can do for all of them if you want. I'm just going to focus on this one for now. And it's still object. That means object is string. It's not numeric. It's not integer, and it's not float or decimal. Float is the same as decimal. So I want to make sure this is numeric because I want to calculate this as a number. The computer's not interpreting as number right now because of that comma. So I didn't actually know how to do it, and I just went online and I found out how to do that. And there is a set of functions from this library here, import locale, from locale import atf. And you run this code right here, which is already written for you. There's more details here. And then you can map it in this way as well here. You actually don't need this part as type integer. I just added that at the end. So that will convert any float to integer because we're not really dealing with floats, we're dealing with integer. So you may not even need this last at the end here, but you do want this code here and it's already written out for you. So you just run it essentially once you have everything ready to go. If you leave the money sign there, this operation is not going to function. So this is just focused when the only thing you have is commas there. And then if you run the data type again, you see that that one that I ran on, GDP 2020, it did change to integer. And then I went ahead actually, and I did the same for taxes, because if we look into the state taxes data, I also noticed that this was probably not numeric data type because it had the commas on. So here's 10,255 155, and it looks to us that it is a number, but for the computer, this is not a number, this is a string or an object. So we wanted to apply and remove those commas there so we make sure it's a number. So I went ahead and did it right here. And then if you check for the state taxes, for the total taxes only, and you can apply later for the other kinds of taxes if you want, but for the total taxes only, it did change with this function. So it's kind of a beautiful thing. So after that, we are going to aggregate counties into a state data frame. So how do we do that? Well, we're going to use this group by function here. And there are two parts to it. So we have this, so let's read the instructions here. Creating a state data set for taxes from county data set by calculating sums and averages of all counties combined or grouped by each state. One or more fields will need to be summed, the others will need to be averaged. So if we take a look at this county data, let's take a look at this county data here. Where was it? County data, county poverty data. We have poverty estimate. So this is the population of people in poverty. So maybe a better name would be poverty population. Poverty percent. So that's the percent of the population of that place, that county, in poverty. And then we have median household income. Okay. So if we aggregate these, some of these, you cannot just sum all of them because you're going to have some meaningless numbers. So some of these have to be averaged and some have to be summed for you to group by and create a state data set because we want to create state measures for these. So I'm going to let you figure out which ones it is. It's pretty simple. So, and I kind of already hinted here because the code is here. So the first line of code is grouping by, and you have to know what to group by, and we're going to group by postal code because as you look up above, all the counties have the same postal code. So all the counties that have the same postal code will be grouped together with the function listed in the operation. So all the counties with postal code LA will be grouped into LA, which is Alabama. All the counties with postal code MI are going to be grouped into one for Michigan. So this is the county poverty data, then dot group by. So this is going to apply the group by function, and it's going to group by postal code. And then here, add function here. This is where you're going to add. It's just one function here. You have to know if it's sum or average, that is mean, sum or mean. And then what I do is actually I remove the other ones, because if you group by postal code and you just do for the whole data frame, you're just going to sum or average everything. But as I said, some have to be summed and some have to be averaged. So I did one here for poverty estimate number, and then I dropped the other ones, the poverty percent and median household. Okay, and so I got the correct number here. I also dropped the index. I didn't drop the index. What I'm doing this one here is I'm taking the index value, which is the postal code here. And notice how, because I grouped by, I created this new axis here. They call it axis here. And this is axis 1. When you see axis 1, that means the columns. But because I grouped by, created a new axis here, and that's the index, and it sometimes behaves a little differently. So I actually created a new column here, and just took the value from the index and put it into this new column. And then I can use also this as the normalized one that how you use to merge the data. So if you notice, it's the same. It's just that this one here is on the major column axis here, and it has a new name, postal, for the data. And if you also take the look of the length of the data, it should be 51, I think. If it's 50 states plus District of Columbia. So that looks good, and that's the one for poverty estimate. And then they have to do another one for the other variables, okay? Because they are, once again, the group by function is different. So you need to know if sum goes here or mean goes here, and then the other one that goes there. And then it's the same thing, and then I dropped the other one that didn't get included in the group by. I created a new postal column for this one as well from the index, and I put it here, see postal here. and just checking it out, and it looks good. And then now I have as one data frame for poverty percent and median household income, which were grouped by one specific function. And then I have another one for poverty estimate or the poverty population. So I had two, and then I wanted to merge them. And we're going to be doing quite a few merging operations, which is in other contexts, like database context, it's called join. So sometimes I call these join or merge, or sometimes I even use both words to include so people know what I'm talking about. So the main operation is here, PDs for the pandas library, and then we're using the merge function. And then here's the data frame on the left side, state poverty percent, and then data frame on the right side. Now for this one, it doesn't matter because they all have the same exact number of columns and the exact same, they should have values for each, the exact same number of rows, not columns, exact same number of rows, 51 states each, and you can double check. And all the rows have values and all the columns have values, but we need to know what we're going to merge on, the main key field. And that's why, and they have to have the same name. This is why we're going around making sure they have the same name. And I changed the name for both of them. And then how equals left. Left means that the join is primarily based on the left data frame, which is here. So this is the left and this is the right. The first one is the left, the second one is right. So that means that we're going to take everything that exists on the left, and then for those that match from the right, we'll put it there. So if there's extra stuff on the right that we don't want, it's not going to include it because this is called a left join. The left takes primacy here. And this will, in this case, it doesn't really matter because they both have 51 rows, but in other cases, it will matter. And then after you do the join, you should see poverty percent. So notice the aggregate, and now we created, because we're creating for the state, right? We had counted, now we created for the state. So we have a poverty percent for the state. We have median household income for the state. And we also have a poverty estimate. So you got to make sure you can't apply average to all and you can't apply sum to all. So make sure you do that correctly. And I'm going to pause here and then continue in the next segment.